Okay, when we look at the list of things that we're going to consider, the last one we were going to consider is Descartes' rule of science. This particular rule is really going to tell us about what is the nature of the types of answers that we get to a polynomial. Let me think. You know what? Let me not do that. Okay. So when we look at this particular function, some of the things we're supposed to remember, how many roots are we expecting to this problem?
5.
5. Just out of curiosity, at the moment, could we identify the fact that it is 1 at one of those roots, just by the test that we just did? So if I took 4 plus 6 minus 14 plus 5 plus 6 minus 7, is that 0? Yeah, I actually don't know either. I wasn't trying to write it that way. If it does, it just...
It is, yeah.
Okay, yeah, I guess it really is. It's minus 21 and plus 21. It does work out. I wasn't trying to do that this time, but that's okay. We've got that one. We could list those possible fraction answers, possible rational roots, couldn't we? But something else that might be important for us is how many of those 5 answers are positive number answers?
3.
We don't know that.
Yeah, we do. Because
How do
one
you
of them is 1.
We know one of them's 1, but how do you know
And
3?
the other 2 are conjugates.
You don't know that.
Oh.
Not by what we've done so far. You might have graphed it and noticed something, but we don't know any more than just that we have 5 answers, and we could list the possible fraction answers. And we also sort of know that 1 is going to be one of those answers, right? So what Descartes said is he said, now we're going to come through this problem and we're going to say, I started a positive, and as I move my way across the problem, I'm going to count how many times do I change from a positive value to a negative value, or from a negative value back to a positive value. We're going to count those. So the work way across, I'm starting positive, there is 1 sign change to a negative, right? And then here's a second sign change back to the positive, and there's a third sign change. So he's saying there's 3 sign changes in this problem. Here's what this means. With those 3 sign changes, that tells me that there is either 1 or 3 positive real roots. Now, it's not saying they're rational. It says they're positive, so they can include square roots, cube roots, things like that in these answers. Why do I go 1 or 3? Why not 2? Have to do with you mentioned a minute ago. The complex come in what kind of groupings?
2.
They come in pairs. So 3 sign changes says there's 3, but if we reduce it by a potential complex pair, then there's 1. Now, we know, because of what we did earlier, there is 1. It's a number 1. So we know there is 1 positive. And we would then lead ourselves to how would we factor that, or how would we use synthetic division on that. He also has a test for negatives. And here's how that works. I will replace all the x's in this function with a negative x. In fact, I would make a substitution, g of negative x, and then I want to simplify that and see what happens. So this is 4 times negative x to the 5th, plus 6 times negative x to the 4th, minus 14 times negative x cubed, plus 5 times negative x squared, plus 6 times negative x. and minus 7. And we would want to simplify this. All the odd powered values go to the opposite sign. All the even powers stay the same sign. So negative 4x to the 5th plus 6x to the 4th plus 14x cubed plus 5x squared minus 6x minus 7. Now we ask ourselves, how many sign changes? So we have, here's a negative, there's a positive, that's 1. There goes negative, that's 2. So yes, there's 2 sign changes. You see that? Any questions about that? Now, because there's 2 sign changes, what possible answers do I have to this problem? 2 possible negative answers, or
1.
0.
0. You're going to drop it by 2 being conjugate pairs. So either 2 or 0.
What about 4? Would there be 4?
Negative roots. How many sign changes did I have?
2.
You can't exceed the sign changes. All right? Also, by the way, if you want to check for negative 1, if you add those coefficients this time, then you get 0 again, negative 1 works. Doesn't happen in this case. But when you're doing this test, if you add the coefficients, you can talk about negative 1 as a possible answer at the same time. Do I have questions about that? Yes?
I don't understand where those zeros came from.
It's possible that we have a conjugate pair of solutions. If that's true, then I may not have that 2 negative answers. I may have 0 negative answers because I could have to pull out of my possible solutions the conjugate ones that aren't positive or negative. Do this for me. Graph the original problem. Graph the original problem. How many times does it touch the x-axis?
3 times.
Of those 3 times, are any of them negative? Are any of them positive?
Yep.
I know one is positive 1. That's one of the spots. The other 2, are they negative or are they positive?
Negative.
So what it's telling me is the 2, they're going to be negative, possible answers. And 1 is going to be the other one. That's 3. The last 2 are going to be complex. Yes.
So we have 5.
Did you hear what I said? 2 of them are negative. 1 of them is positive. The remaining 2 are complex. That's 5. Okay? Now, I'm not sure I've answered the question in the back, though. So ask me your question again.
I still just don't understand why it's 0. Like, how do you know? Like, if it's either 2 or 0. Like, why couldn't it just be 2 or 1?
Oh, because we're always going to reduce it by the pair that could be conjugate. That's what I did up here, too. I had 3 sign changes, 1 or 3. Reduce it by that pair. I can't reduce the 1 by another pair. That's negative. That doesn't make any sense. But if I got 4 sign changes out of something, it's possible 4 roots, 2 roots, or 0 roots because of the conjugate pairs. If you can reduce it by a 2, you will as an option because of conjugate pairs for solutions. That's why it's 2 or 0. It's a conjugate pair possibility. The graph verifies it's only 2. So we want to put those pieces together. Question?
If that to the 4th, does that stay positive because of the
Even power. Yes, that's what it does. Other questions? I'm a little hesitant to figure out. Can somebody use their decimals and tell me the negative answers? Are they going to be our rational ones or are they going to be something weird?
Weird.
Okay. Okay. I was afraid of that because I wasn't really trying to find a solution. I wanted to talk about the Karch rule of signs here. Any other questions about this? Guys, we need to practice this stuff. You've done a little bit of this process in the past. We're going to start putting the pieces together a little bit more, and there's a lot to this. But you really need to practice this stuff.